Hi, I'm Mini from EC department in Emmanuel Arasar JJ College of Engineering. Today, I'm going to explain the topic LCD. First of all, what is mean by LCD? That is liquid crystal display, right? Okay, this liquid crystal display. From the name, first you identify what is liquid crystal and display. You all know display, isn't it? So, what are the things we see on the board? That is what display, right? Liquid crystal, liquid, normally liquid crystals are, or liquid is a molecule, okay, which can flow, but solid is the thick statement, okay, or thick, one of the thick matter, okay. But liquid, it's actually liquid is a molecule which can flow. uh, what is about liquid crystal? Liquid crystal, that is, that molecules are partially ordered, not perfectly fixed like a solid. Okay, in solid they are perfectly fixed, but in this liquid crystal, it is completely random. There is no order. That is what liquid crystal. Okay, so simply we remember that liquid crystals are intermediate state, right, between this solid and liquid state. Okay, so as we know liquid is the flow of molecules, and solid is the thick state, thick matter. Between, that is, in between that, we can say that as the intermediate state, which is what liquid crystal. Okay, so this is the basic about liquid crystal display. So we all know now what is display, what is liquid, and what is liquid crystal, right? Once again, display is what are the things we visible on the board. That is what display. Liquid, it's the flow of molecules, but liquid crystal, it is also the molecules, but that are partially arranged, not fixed. Okay, so it will be completely random. There is no order. That is what liquid crystal. Okay. So come under this topic, liquid crystal display, that uses liquid crystals and electric field to control the light transmission and produce the images. How the images are produced using this display device? It uses liquid crystal. As we already know that liquid crystal, what is liquid crystal, right? And electric field. Now we know, we should know what is electric field, right? What is electric field? We see that if the electric field is applied, these molecules can change its alignment. From these, it controls the light. This is very useful in display technology, right? Okay, so in this electric field, now electric field is, what is electric field? It's a force, okay, electric field experienced by the positive charge which is placed on particular area. Okay, so what is the basic definition of or basic representation of electric field? F by Q. E indicates that electric field, its unit is newton per coulomb, and F is the electric force, Q is the test charge. Okay, for example, if you bring a small positive charge near a positively charged rod, okay, it will be repelled. This repulsive force occurs because of this electric field around the rod. Okay, this electric field is created by electric charges that can attract or repel other charges. Okay, so this is what electric field. Okay, so if this electric field is applied in this liquid crystal, okay, these molecules can change its alignment. Alignment means that is what arrangement. Okay, so if this electric field is applied, it will controls the light, right? This is very useful in display technology. Okay, so in liquid crystal, neither it may be solid or liquid, but have the properties of both. Okay, it does not emit light, but it requires a backlight. this image is how the image is formed by controlling the light through the crystal. Okay, now actually this LCD, how this LCD is visible, it's a flat panel display technology that uses liquid crystal to control light and produce the images. Okay, it actually does not emit light directly. Okay, it uses the backlight. It uses the backlight. Then only the image is formed by controlling light through the crystals only. Okay, so the basic working is, when we not apply the voltage, okay, the crystals are twist and the light passes, therefore the pixels looks very bright. Okay, when we apply the voltage, what happened, crystals are alignment. Okay, so that time the that backlight, it will block the light. Okay, and now the pixels looks dark. Okay, so what do you understand from this? If you are not apply any voltage, it looks bright. Okay, the pixels look bright. Why it looks like bright? Because of light passes through the crystal. Okay, but if we apply the voltage, what happened, the crystals are arranged, that's why it blocked the light. Okay, and that time the pixels look dark. Okay, then what's the next one? Okay, this is the what see this is the basic structure of liquid crystal display. Then this the LCD is mainly composed of 5 units. Okay, what are the units? First one, BLU, POL, LCD, IC, and FPC. What is BLU? Backlight unit. Okay, what is BLU? Backlight unit. Actually, this uh, BLU is the light source. You all know what is source. Source is the, that is source of energy. Example, what is the source of light? Sun is the source of light, right? So it takes the energy, and it is active, and it gives the energy to the other. Okay, that is what source. Okay, where we take the energy, that is the source. Okay, if I speak means I am the source. Okay, so I take the energy and gives to another. Okay, so BLU is the backlight unit. It is the light source where it is placed behind the LCD panel, and it provides illumination. Okay, and it provides illumination. Now, what is illumination? That is amount of light falling on a surface, or it tells how bright a surface is. Okay, and how to measure illumination in lux, lux, lux. Okay, 1 lux is 1 lumen per square meter. Okay, then what is that, if it is higher illumination, more light falling, we consider that we will understand, more light falling, it will be higher illumination. If it is less light falling, the illumination is very lower. Okay, now in this BLU, so how this BLU is needed, why this BLU is needed in LCD, since liquid crystals do not produce light. Okay, because it arranged in order only, not order, it is randomly arranged. Okay, but if BLU is employed in this LCD panel, okay, it only have to control or block the light. So BLU supplies the required white light. Okay, so that purpose we need this BLU. Okay, I think you all understand what is BLU. It is backlight unit. It's the light source which is placed behind the LCD panel. It provides illumination. What is illumination? Amount of light falling on a surface, or it tells how bright a surface is. Okay, so and this light is falling on the surface. Okay, then this liquid crystals do not produce the light, but it only controls or block the light. So BLU supplies the required white light. Okay, what's the next one? What's the next one? Okay, polarizing filters are, we can say that polarizer, POL is otherwise called as polarizer. Simply we remember this polarizer is to control the light direction. Okay, control the, okay, polarizer, it's control the light direction. How it controls the light direction? This polarizer is a optical filter. Okay, filter. What is filter? It rejects the unwanted things, right? Optical indicates that light. Optics means light. So this polarizer is a optical filter that allows light waves vibrating only one direction, okay, to pass through and blocks the others. If it is normal light, it vibrates in all the direction. After polarizer, vibrates in only one direction. Okay, so this it's the in polarizer, the important thing is it controls the direction of light waves. Two polarizers are used. What are they? Front polarizer and back polarizer. These two polarizers are perpendicular to each other, that is 90-degree to each other. Okay, if the light is blocked, or if uh, how it control the light, because it arranged 90-degree to each other. Okay, so from this, due to use this, the light will be blocked. Okay, if it is aligned, the light passes. Okay, now what's the next one? LCD. Already we see that what is LCD, that is liquid crystal display panel. Okay, now next one is IC. Yeah. So already I explained that this BLU, any, etc. So once again, what is BLU? It is a backlight unit. Okay, this backlight unit is one of the key component of LCD. It consists of multiple layers of optical sheets and the light source. The role of backlight is sufficient brightness and evenly distribute the light source to the LCD panel given the liquid crystal molecules. It cannot light themselves. Okay, normally this light source is the LED strips. So it is also called LED backlit. What is that lit? The light falling on the surface. No, that is what backlit. Okay, the quality of the backlight determines how important features of the display, such as the brightness, uniformity of the outgoing light, and color level of the LCD screen. In general, the BLU largely determines the luminous effect of the LCD screen. Okay, so simply you remember what is polarizer. Polarizer, it's the optical filter, right? It allows the light waves. Okay, so it converts the natural light without polarization into polarized light and control uh, which light patterns can pass through the LCD panel, right? Without these filters, visual images generated by the LCD panel have poor performance in contrast ratio. Okay, now IC integrated IC integrated circuits. Okay. What is that IC integrated circuit? IC is an electronic chip, as we know already, right? It controls the operation of the display. Okay, especially how pixels means picture element. Okay, how the pixels are turned to on or off. Okay, this IC integrator circuit maintains timing and synchronization. Okay, so this pixels, a screen is made of what is pixel? A screen is made of millions of tiny dots. Each dot is equal to 1 pixel. All pixels are together form the complete image, right? Each pixel contains 3 subpixel. What are the subpixels? Red, green, blue. If we combine these different colors, if we combine these three, we get the different colors. Okay, so that is what integrated circuit. Okay, so integrated circuit is a chip device that consists of set of integrated circuits. What is the purpose of this? What is the use of? Is used to adjust and control the phase, peak value, frequency, and other parameters or potentiometric signals on the transparent electrode to establish the driving electric field and finally realize the information displayed on the screen. Okay, so phase value, right? Positive phase or negative phase. Okay, so peak value also, amplitude, total value is the peak value. Frequency is number of cycles per second, the unit is hertz. Okay, some of the other parameters also used to display the information on the screen. Okay, then what's the next one? FPC. So this FPC is the abbreviation of flexible printed circuit board. Okay, what is FPC? Flexible printed circuit board. Okay, by connecting the LCD panel, FPC can realize the working principle of the circuit and the output, the interface that the motherboard needs to match so that the LCD can work from an electrical point of view. Okay, so simply we understand this FPC is like a bendable wire circuit, right? It carries electrical signals. Okay, so electrical signals, maybe voltage or current, right? This electrical signals between the components, it can bend and fold without damage. Okay, what is the main function of FPC? It transfers the image signal from IC to pixel. Okay, from IC to pixel, right? Next one, that is LCD panel or cell layer, LCD crystal display, right? So from the introduction itself, we clearly explained what is LCD, right? So here in this liquid crystal display panel, it's the packaging of liquid crystals embedded, that is employed between two glass substrates. A top glass substrate with color filter and a down glass substrate with thin film transistor array. Okay, is that TFT array? That is thin film transistor array. It's the layer of many tiny transistors. Transistors, there are two types of transistors, no? BJT, FET, okay, bipolar junction transistor and field effect transistor. Commonly, we are used that FET only. Okay, in BJT, some what are the configurations are there? Common base, common emitter, common collector. Compared to all others, common emitter is mainly used, right? So here this TFT, it's one of the array. Okay, so many tiny transistors, tiny small transistors, right, are arranged in rows and columns. And what is the purpose of this? Used to control each pixel in a display like LCD or LED screens, right? And what is the simple definition of this TFT? TFT is a grid of thin film transistors where each transistor acts as a switch to control the light. Okay, and the color of a single pixel on the screen. This TFT, how it works, each pixel on the screen has its own transistor. I already told, no? This transistor controls the voltage applied to that pixel. That decides the brightness and color of that pixel. All pixels together form the image you see. Right. You simply remember TFT array, a system that controls every small dot or pixel on your screen. Okay, where we used mobile phones, televisions, laptops, computer monitors, right? Example. Okay, this TFT array screen should be blurry and slow. It helps in getting clear, sharp and fast images, right? So this is what TFT. It is also called LCD panel and is an essential unit of the color display. On the TFT substrate, it can control the pixel voltage on the side preciously, and it is the pixel voltage applied to the liquid crystal that controls the twist of the liquid crystal, right? On the CF substrate, okay, a pixel, CF substrate means what? So on the CF substrate, a pixel is divided into the three subpixels, red, green, and blue, right? So from this, we have one doubt. What is that CF? What is CF color filter? Okay, it's an optical component. Okay, optical, that is light, no? Optical component that transmits certain wavelength of light and absorbs or block the rest. Okay, if it is a red filter, it lets only red light pass. Okay, if it is green filter, it lets only green light pass. Blue means it will pass only blue light. Okay, other colors are blocked. That is what CF filter. In CF, in color, what is the main purpose of this color filter? A layer that select and shows only one color of light. Okay, example, if you wear red sunglasses, everything looks reddish because the filter allows mainly red light, no? Same as here also. Okay, this in display techniques, that is LCD, this each pixel has three subpixels, red, green, blue. Color filters are placed on them. By mixing these colors, millions of colors are produced, right? In this liquid crystal that acts as a light valve, adjust the amount of light of the three primary colors RGB passing through the CF substrate, and the desired color display can be obtained. Okay, then next one, working principle of this LCD, how it works. LCD is a product of, okay, LCD is a product of optoelectronics. What is optoelectronics? It's the branch of electronics that deals with devices that convert electrical signal into light and light into electrical signal. Okay, we can study and application of electronic devices that produce, detect, or control light. Okay, how it works? This optoelectronics, optics. The from the name you understand, optoelectronics, that is electrical energy is used to convert the light, and the light converted to electrical energy. Okay, so where we used this optoelectronics, TV, mobile display, optical fiber communication, remote control, solar panel, etc. Right? This light can be divided into different polarization direction. If the lights with different polarization direction pass through a liquid, okay, and there will be different optical path. After the light is recombined through this optical path difference, it will change the form of its polarization with the polarizer blocking the light in a certain polarization direction. The transmittance of the light can be determined. Okay, then the next one, sort of electrical perspective. Okay, from the electrical view, under the different voltages, the liquid crystal will have different arrangements. Different liquid crystal arrangements cause different optical path differences, thus making the transmittance change, so that the video signal can be converted into the bright and dark display light. Okay, now arrangement, how the arrangement is there. Crystal is made up of organic molecules. This individual molecules have a rod like appearance. Different arrangement of rod like molecules are pneumatic, smectic, and chiral or colstric. Okay, now we see one by one. What is okay, pneumatic phase? In pneumatic phase, molecules are randomly positioned but aligned in only one direction. Okay, there is no any fixed layers. Most commonly used in LCD, TN displays. Okay, the in pneumatic phase, the main point is only directional order, no positional order. Okay, but okay, no positional order, only directional order, no positional order. So what is mean by directional order and positional order? Directional order means molecules are aligned in the same direction even though they are not fixed in position. Okay, this is what directional order. But positional order means molecules or atoms are arranged in fixed regular pattern in space. These molecules stay in fixed positions forming a pattern. Okay, yeah? So simply you remember directional order, same direction, free position. Positional order, fixed position, regular pattern. Okay, the next one is smectic phase. Here the molecules are arranged in layers. We can see that sheet like structure. Okay, within each layer molecules are aligned, more ordered than pneumatic. When compared to pneumatic, this will be more ordered. Just remember that both directional and partial positional order. Okay, so as we already know what is directional order and positional order, so here both will be directional but somewhat partial positional order. Okay. Now the next one is chiral pneumatic phase or cholesteric. Here the molecules form a helical structure. We can say it is otherwise called a spiral structure. Okay. As we see already, spiral you all see, right? We are keeping the books or so many papers are spiraled, right? So did you see that spiral how it looks? It will it that is it is a helix in structure. Okay, so here the orientation changes layer by layer. Okay, the purpose of this, it reflects the specific wavelength of light used in special displays. The important thing is this helix is twisted structure, right? Twisted structure. See the image. This is the this is the image. How the arrangements are there. Okay, smectic phase, pneumatic phase, and cholesteric phase. Okay. Then types of LCD. So many types of LCD are present: TN, IPS, VA, STN, TFT. Okay, what is TN? That is twisted pneumatic LCD. IPS, in plane switching LCD. Okay, what is that? Vertical VA, vertical alignment LCD. Then STN, super twisted pneumatic LCD. TFT is thin film transistor LCD. Okay, so first we see about that TN LCD, that is twisted pneumatic LCD. See the diagram. This is the diagrammatic representation of TN twisted pneumatic LCD. This TNLCD is the most basic and widely used type. Okay, these liquid crystals are twisted in structure. How much it was twisted? 90-degree twisted. Okay, it's the fast response time. The only advantage is low cost and fast switching. It have the disadvantages also because the viewing angles are very poor. Okay, the color quality also lower. This is what twisted pneumatic LCD, right? Then the next one is what okay, IPS. What is IPS? In plane switching LCD. Okay, this is the diagrammatic representation of IPS LCD. Here the crystals move parallel to the screen plane. It provides better color accuracy. What's the main advantage of this IPS LCD? Wide viewing angles, better color reproduction, and the main disadvantage is it's more expensive. So we are not used regularly. Okay, and it's slightly slower than TN. Okay, yeah. Then next one, VALCD. What is that VALCD? That is what vertical alignment, right? In this VALCD, here also see the diagram. This is the diagrammatic representation of VALCD. Here the crystals align vertically when no voltage is applied. Okay, if you are not apply any voltage, the crystals align vertically. It provides high contrast. Okay, the advantages are it looks deep blacks and good contrast ratio, but its disadvantage moderate response time and viewing angles less than IPS. Okay, so what is contrast ratio? It's the difference between the brightest white and the darkest black a display can produce. Okay, so that is simply you remember what is contrast ratio, how bright the white is compared to how dark the black is. Okay, this is what contrast ratio. And the next one is what? STN. Okay, what is STN? Super twisted thematic LCD. Here also see the diagram here. From this diagram, we will understand how the structure is. This STN is the improved version of TN. It uses greater twist angle. The degree, that is the degree wise 180 degree to 270 degree. Okay, the main features of STN LCD is better contrast than TN. It's used in calculators and old displays. Okay, and the next one, TFT. TFT. What is TFT? Advanced thin film transistor. It is the advanced LCD using transistors for each pixel. Then it have active matrix technology. It have the advantages high resolution, better image quality, and where we apply this TFT, TV, smartphones, monitors, etc. Okay. Then advantages. See the advantages: low power consumption, thin and lightweight, less heat generation, good image quality. These are the advantages of what LCD. Okay, then disadvantages. Some of the disadvantages also in LCD: limited viewing angles, especially TN. It needs backlight, slower response than OLED, and limited contrast compared to OLED. Right? Applications: TV monitors. Next we see about that. Applications: TV monitors, mobile phones, calculators, digital watches, instrument displays. Okay, I think you all know, you all understand this LCD. uh, we just recall that what is LCD, what are the things we understand in this topic, what is LCD, and what are the types of LCD, how this LCD works. Okay, what are the advantages and disadvantages? I think you all understand. Thank you.